Hello children, in this lecture we will start our discussion from a new chapter which is chemical equilibrium. So this chapter is given in two parts. Part 1 is chemical equilibrium and the part 2 is as ionic equilibrium. Okay, so from today we are going to start chapter number 7th A, part 1, equilibrium or chemical equilibrium. Okay students, so first heading is introduction. So under this heading first we will discuss type of reactions on the basis of their directions. So types of reactions on the basis of their direction means in which direction the related reactions are taking place. So on the basis of direction, reactions can be divided in two types. First is irreversible reactions. So these are the reactions which are taking place from a reactant to product. From reactant to product means these reactions are unidirectional in nature. Okay, unidirectional in nature where reactants are forming product. So being a unidirectional nature, these irreversible reactions are completed in a definite time. Okay, and these reactions are shown with the help of this arrow sign, in which the head part of the arrow is pointing towards the product and tail part towards the reactant. Okay, for example, reaction of silver nitrate aqueous with hydrochloric acid is a type of irreversible reaction where these two compounds react with each other forming silver chloride plus HNO3 at once, and after that a reaction will stop. So such reactions will be known as irreversible reactions. Okay, the next type of reactions are reversible reactions, and these are the reactions which are bidirectional from reactant to product and again from product to reactant, and shown by this reversible sign. Okay, so these are the reactions which are known as reversible reactions, in which both forward and backward reactions are taking place simultaneously. Okay, so because these are taking place in both the directions, so these type of reactions can be continued forever if not disturbed from outside. Okay, so these can be continued for the indefinite time period. Example, PCl5 when decomposed it form PCl3 and Cl2. These two again after combination can form PCl5. Okay, so number of examples are given here for the reversible reactions. Second point, when in any reaction which is taking place in a closed vessel, and in such reversible reaction which is taking place in a closed vessel and the equilibrium has reached, then at that condition the reaction is continuous moving from forward to backward and from backward to forward direction. Okay, means the equilibrium is dynamic in nature. Okay, So at the condition of equilibrium, the reversible reaction will be continued from reactant to product and from product to the reactant at equilibrium condition also. Okay. Then third point, this equilibrium term we can apply for the different physical changes or physical processes also. Then according to fourth point, at the equilibrium, the concentrations of reactant and products become constant. Fifth point, equilibrium is dynamic in nature. Then sixth point, equilibrium is established only when no product is allowed to escape out. Okay, so it means equilibrium can be achieved inside a closed container only, not in open atmosphere. Then seventh point, equilibrium can be achieved from any direction. We can start reaction from product to reactant, or we can start reaction from reactant to product. Okay, for example, if you are having a reaction A plus B forming C plus D, okay, and this reaction is in a dynamic equilibrium state. So this dynamic equilibrium can be achieved by taking initially A and B, or by taking initially C and D. Okay, so if you take C and D, then the reaction will start from C and D to A and B, and then this equilibrium will be achieved. And if initially you are taking A and B, then reaction will start from A and B to C and D, and after that equilibrium will be achieved. Okay, so equilibrium can be achieved from any direction, from either direction, from backward to forward or from forward to backward. But after some time, both reactions will be with same rate. Then next point, eighth point. When equilibrium is reached, temperature, pressure, concentration, etc. of the system become constant, and they do not change with time. Effect of catalyst, no effect of catalyst. Okay,